Okay, let's go through the solution. So from what we did before, we're going to get the velocity of the particle from the electron gun as 2 lots of this, which when we put the numbers in, we've got the square root of 2 times 1.6 times 10 to the minus 19 times 3.7 times 10 to the 3, all over 9.1 times 10 to the minus 31. And when you get the numbers on your calculator, that comes out at 3.6 times 10 to the 7, which just as a quick common sense check, you just have a look at, and you think to yourself, well, the speed of light is 3 times 10 to the 8, so that's just over 10% the speed of light, which is around about appropriate for an electron gun. Okay, so now we're going to use that velocity to work out a time of flight. So the time of flight is equal to the horizontal distance traveled divided by the horizontal speed. So the horizontal distance traveled was 7.0 10 to the minus 2, and then we just need to divide by that to give us the time of flight, and that comes in at around about a billionth of a second. So now we've got the time of flight, we can now put that into the equation s equals ut plus a half at squared. Now the initial vertical speed is 0, so we don't need to worry about that. And the time of flight is what we're going to be using for t here. So when we rearrange this for a, we end up with a is equal to 2 lots of the vertical distance, which was 1 centimeter, divided by the time squared, which is 1.9 times 10 to the minus 9. And that will give us the acceleration. And that's going to be a very big number because it's quite a big force on an object that has a very small mass. So that comes out at that for our acceleration. And now we just need to remember that our acceleration is the force divided by the mass, F equals ma. And the force is equal to the charge times the electric field strength, and the electric field strength is equal to V over D. And it's V that we're trying to get hold of in this equation. So if we just rearrange it to get that, where m is the mass of the electron, v is the charge on the electron, d is the separation of the plates, which is 5 centimeters, and a is the acceleration. And when you put all of those numbers in and turn the handle, the answer comes out at 1.5 kilovolts. Okay, so that's how you get your solution. The question is, was it 1.5 kilovolts? Well, the answer is kind of. It was 2.4 on the voltmeter. So it's not too bad considering that we're running on 2 sig figs here, that we're close-ish. However, the biggest issue, if I just show you again on this thing, we've got that the starting point is listed as 2 centimeters there. But there are end effects, and I'm not really convinced about how accurate this machine is in terms of that horizontal scale. If you work the calculation backwards and you put 2.4 kilovolts in as the secondary PD, then you end up with a distance of 5.8 centimeters, which would mean that there's a 1.2 centimeter zero error on that scale. So I think given that we're unconvinced about the accuracy of that scale, 1.5 volts isn't too bad, kilovolts, and the purpose of this exercise was to do the calculation. So as long as you were able to do that, that's that box.